Right, so we used some of these in 5-1 actually, because you learn them, like I've taught them in 8th grade math and Algebra 1, so you should have seen them at least once before. So really this is a review. These properties of rational or of exponents, they're on page 247. So I just copied them down from the book here. Just remembering, okay, if you have the same base, you can add the exponents when they're being multiplied. If the same base are being divided, you subtract the exponents. If you have a base that's raised to a power and then to another power, right, you multiply those exponents. You multiply the powers. If you have a product that's being raised to a power, you have to make sure to distribute that power to each part of the product. So like if it's 16x cubed, you need to make sure it's 16 cubed times x cubed. A lot of times kids will take out the 16 and forget to cube it. And then if it's a negative exponent, all it means is it plops down to the bottom of a fraction. So instead of, you can write it 5 to the negative 1/2, or you can write it as 1 over 5 to the 1/2. So if you don't remember those, you should review them on page 247, and then we're going to do some examples where we apply them. So let's start with these. To use any of those properties, you have to make sure that the base is the same. So here there are 3 examples we're going to do. This first one, the base in both of these is 81. Okay, and it's a product. So that means we can add the exponents. So this is just going to become 81, and it's going to be whatever 5 to the 6th plus negative 1/3 is. Okay, now you're just adding fractions here. That's going to be, if I do some work on the side, it's going to be 5 6 minus, well, what's 1/3? If I make it a common denominator, that's 2 6. Right, and then 5 minus 2 is 3, so it's 3 6. So this becomes 81 to the 3/6 power, which is just 1/2. And 81 to the 1/2 is written like that, square root of 81. Okay, well, I can find the square root of 81, so let's do that. It's either going to be positive or negative 9. Either of those will give me 81. All right, now let's try this one, something a little more complicated, new numbers, right? And there's more than one property here. So the first thing I notice is that there's a 2/3 on all of this, right? But I have 2 x's here, so I'm going to see if I can combine them. So really what I have inside the parentheses, if I just deal with the inside first, is I have a quotient. I have x to the 1st power over x to the 1/2 power. So that means I can subtract them, right? So it's going to be x to the 1st minus 1/2. So really that means that what I'm left with is just a 1/2 on the top, because 1 take away 1/2 is 1/2. And I still have y cubed. Now I've cleared out my denominator, so I don't have that anymore. And I still have the 2/3. Now I need to distribute that 2/3 to each part of this product, right? So this is going to be x to the, well, what's 1/2 times 2/3? That's 2 over 6, right? Times y, what's 3 times 2/3? Well, that's just squared. So then I can rewrite it, that's x to the 1/3 times y squared, which then I can rewrite it as y squared times the cube root of x. Okay, let's try one more. Here we've got the cube root of 16 times x to the 5th. So I'm trying to see if I can take anything out of this cube root. So I'm going to see if I can find some cube roots here. Let's see. I know I can't find the cube root of 16, but I can find the cube root of 8, right? Because the cube root of 8 is 2. So I'm going to break up 16 into 8 times 2. And then, so I can take one group of 3 out of here, I'm going to rewrite this as x cubed times x squared, right? Because I can add those exponents back and I would have x to the 5th. So now I'm just going to do some thinking here. The cube root of 8 is 2, so I can take that out. And then I know I can take the cube root of x cubed is just going to be x. So I can pull those 2 things out from under the radical. So now I have 2, taking that 2 out, and then I have x, taking that x out, but I still have the cube root of what's left under there, a 2 and an x squared. Okay, I can't take anything else out of that radical, so this is my final answer here. Let's try a couple more. These say simplify, but that's pretty much what you were doing. The directions for the last one are like use the properties to simplify, but that's what you're always doing. So let's look at these. We have the fifth root of 16 times the fifth root of 8. So what makes this tricky is our bases aren't the same. One base is 16 and one base is 8. But because they're both the fifth root, we can combine them into one radical. It's going to be the fifth root of whatever 16 times 8 is. Because the power of the radical is the same, we can combine them. And 16 times 8 comes out to be the fifth root of 128. And then now I'm trying to see if there's factors that I can, like if I can break this up into two factors where I can take the fifth root of something. And I know I can break this up into the fifth root of 32 times 4. And that's helpful because I know the fifth root of 32 is 5. So I can take the fifth root of 32 out. I think I said it's 5. I meant it's 2. The fifth root of 32 is 2. And then I still have that 4 in there. And I don't know what the fifth root of 4 is, so that's my final answer. It's the most simplified. All right, what about this one? We've got the sixth root of 8x times the third root of 2x. Now, my powers on my radical aren't the same, so I can't combine them. So let's just rewrite it like this. See what happens here if I rewrite like this. That's a bit helpful because now I'm looking and I have two like bases, an x and an x raised to power, so I can most likely combine those, right? But then I'm also thinking I could think about how could I make these the same, right? Could I make the radicals be the same power so that I could combine them together? So could I, and sometimes this will just be some trial and error, if I leave that 1/6, I could rewrite that as 2x to the 2/6, right? Because 1/3 is 2/6. So now they're almost the same, but to be able to combine them exactly like I did here, I need this to be 1/6. So that means I could rewrite it like this. What? Let's distribute that 2 in. It'll be 2 squared times x squared. Now I have 1/6 out there. And this is helpful because now I can put them together under the same radical. So what do I have? I have the sixth root of 8 times x times 2 squared is 4, so I'm going to write 4 times x squared. If I combine those, I have the sixth root. Well, 8 times 4 is 32. And then I have 3 x's, so that's x cubed. I can't find the sixth root of 32x squared, so this thing right here is my most simplified solution. All right, let's try a quotient. The cube root of 2n over 9m. Okay, so the first thing I want to do here is let's try to see if I can break these up into two separate quotients and if I can simplify them at all. Alright, so I have the cube root of 2n times the cube, or over the cube root of 9m. So sometimes, now I'm looking at this, I don't know what the cube root of 2 is, and I don't know what the cube root of 9 is. I don't know those. So it's looking like I can't simplify. Sometimes if you're stuck in this spot, you can do something which is called rationalizing, which maybe you've heard before. Rationalizing means to take the square roots out of the denominator. And really, from this point on in math, you can't leave any square roots in the denominator. It's considered unsimplified. So you'll never see a simplified solution that has a root in the denominator. So then you're like, well, how do I take the square root out of the denominator? Well, you just multiply it. It's not a square root. How do I take the root out of a denominator? So if I had the square root of x, right, and I wanted to take the root out of the denominator, I could multiply it by the square root of x and I would just get x. So I've cleared it out. Okay, so the same thing is here. I need to figure out what I need to multiply this by so that the cube root is gone. Well, in order for the cube root to be gone, I need 9 to become a perfect cube. I know I can make 9 a perfect cube by multiplying by 3, right? Because 9 times 3 gives me 27, and the cube root of 27 is 3. How can I get m to be a perfect cube? Well, I have 1 m. If I multiply it by 2 more m's, I'll have 3 m's that I can then take out of the radical. And so whenever you're rationalizing, whatever you figure out you need to multiply the denominator by, you also have to multiply the numerator by, right? Because now I'm essentially multiplying by 1. So let's go ahead and do this. The easiest thing to do is going to be to figure out the denominator, right? So this is going to become the cube root of 9 times 3 is 27, and m times m squared is m cubed, which is what I want it to be. Now it's a perfect cube. And now what happens up here? This is still a cube root. We can combine them because the power on the radical is the same. 2 times 3 is 6. And now we have an n and then an m squared. All right, so now let's see what we have. I'm going to leave this here. And this, my perfect cube is now, the cube root of 27 is 3. The cube root of m cubed is m. So this, looking at it, I can't do anything else to the top. There's nothing I can factor out. So this is my final answer. And it's simplified simply because there is no radical in the denominator. Okay, now let's try a couple where we're going to do some operations. So if you're adding or subtracting radicals, before you start figuring out what each one individually, you can start seeing if you can make some of the radicals like, or the powers like, so you can combine them. So what do I mean? So root 20. I don't know the square root of 20, but I know I can break that up into 4 times 5, and that's helpful because the square root of 4 is 2, so that's 2 root 5. All right, minus. Now let's deal with this next thing. I don't know the cube root of 16. But I know I could break that up into the cube root of 8 times 2. And why is that helpful? Because I know the cube root of 8. The cube root of 8 is 2. So I could factor out that 2, and then I'm left with the cube root of 2. Now let's look at this one. The cube root of 250. I don't know what that is. But I do know that 250 is 125 times 2. And that's helpful because back in 5-1, we figured out the cube root of 125 is 5, right? So I can factor out that 5, and then I'm left with the cube root of 2. Minus the square root of 5, there's really not much I can do there. So I'm just going to leave it, and then I'm going to rewrite it down here. So now let's look. Can anything be combined? Here I have a root 5. Nothing else to combine. Right? Oh, yeah, here's another root 5. So I have 2 root 5 minus root 5. So what is 2 root 5 minus root 5? Well, that just leaves me with 1 root 5, because I can put a 1 here if that's helpful to think about it. 2 minus 1 is just 1 root 5, so that's root 5. Now let's look at what's left. We have a cube root of 2 and another cube root of 2. So I can combine those. This is negative 2 cube root of 2 plus 5. So I'm looking at the numbers in front. Negative 2 plus 5 leaves me with a positive 3. So this is plus 3, and then we have that cube root of 2 on the back. So this is our simplified answer. All right, let's try one with multiplication or division. Well, I think this is just multiplication. So we've got the cube root. Oh, I think I had another one I didn't write, so I'll do that one here. The cube root of 7 times 2 minus the cube root of 49. So we've got to distribute that cube root of 7 in. So we have 2 times the cube root of 7 minus, okay, they're both cube roots, so we can figure out what 49 times 7 is. I did that on the calculator. You end up with 343. This can't be factored anymore, 2 cube root of 7. But the cube root of 343 is 7, so you can leave it just like that. That's our final answer. And I wanted to try this one, which I forgot to write down. So let's add that real quick. So when you have something like this, you can use those same rules of multiplying binomials that we did back in the beginning of the school year. Like I told you in that video, I don't have those memorized. I just think about it in my head. So what's 2x times 2x? Well, that's 4x squared. Then I have 2x times negative root 3, and then 2x times negative root 3. So if I'm just going to write that out so you can see what's happening in the middle. And then at the end, we have a negative times a negative. That's positive. And what's root 3 times root 3? Well, that's just 3. So really now I need to just focus on combining those. So it's 4x squared minus 4x root 3, right? When you combine those, you get negative 4x root 3 plus 3. And finally, before we go, let's try one more where we're going to rationalize. So remember, the point of rationalizing is to take the square root out of the denominator. So a lot of times you'll end up with a sum or a difference in the denominator. And what you need to do when you're rationalizing that, the way you would get rid of that root is by multiplying by the conjugate, which would be 2 minus root 5. So we're going to multiply both the numerator and denominator by the conjugate. This is the conjugate. And you could quickly work out what's going to happen. You end up with 2 times 2, so you'd end up with 4 minus 2 root 5 plus 2 root 5, so that middle term cancels out. And then finally it would be it'd be minus just 5, because we'd have root 5 times root 5. So what does that leave you with on the bottom? It leaves you with the square of the first number, which is 4, and the square of the second number, which is 5, and then we are subtracting them. And then what would the top be? Well, it would be this, because it's just times 1. So we can simplify it a little bit by writing that over negative 1, which just means that whole thing is negative 2 plus root 5. Okay, do some practice problems, and I'll see you next time. Bye.